Directional control valves are used to stop, start, route, and divert fluid streams without affecting the pressure level or the flow rate of the system. Directional control valves are identified by the number of ways that fluid can flow and the number of positions the valve can produce. A way refers to the number of active porting connections, called ports. This valve has 3 ports, so it is a 3-way valve. The term position refers to the number of discrete operating positions of the internal valve element. For this spool valve, one position allows fluid to flow from the inlet to port A, and a second position allows fluid to flow from the inlet to port B. Therefore, this is a 2-position valve. This spool valve has 2 ports and 2 positions. The first position allows fluid to flow freely. The second position blocks both ports. Even though both ports aren't physically blocked, the lack of fluid entering the pressure port also prevents fluid from exiting outlet port A. Therefore, both ports are defined as blocked, making it a 2-way, 2-position valve. To simplify fluid system drawings and schematics, all valves can be represented graphically. Boxes, sometimes called envelopes, are used to indicate the number of valve positions. Since this is a 2-position valve, its graphic representation has 2 adjacent boxes. Continuous lines are used to indicate fluid flow between ports. For complex valves, the ports may also be labeled. The input port is typically labeled P for pressure. Outlet ports are typically given alpha characters starting with A. Other times, the letter stands for the destination of the fluid. For instance, the letter T would indicate a port that is connected to a tank. This is a fairly simple valve, so port labels are not required. A solid arrow indicates the direction of liquid flow. The first position of this valve allows fluid to flow from the pressure port to port A, so an arrow is drawn in the first box to indicate fluid flow. A T indicates that a port, or way, is blocked or closed. This valve's first position has no ports blocked, but its second position blocks both. The second box corresponds to the second position of the valve. Therefore, 2 T's are added to illustrate the lack of fluid flow in the second position. Next, lines are drawn to indicate the normal position of the valve. The normal position is defined as the position of the valve when its spool is unshifted and the power is off. This means that any mechanical actuators, such as springs, are in their non-actuated positions. Electrical actuators, such as solenoids, are powered off. The normal position can sometimes be referred to as the unshifted, de-energized, or unactuated position. In this case, position 1 is the normal position. Therefore, the lines to indicate the normal position are drawn in the first box. On a hydraulic schematic, the lines that indicate the normal position will be connected to other devices in the system. Valves that do not have mechanical or electrical actuators do not have a normal position because they must be manually moved. When shifted, they remain in that state until manually shifted to another position. The terms normally opened and normally closed are used to describe the condition of a valve when it is in the normal position. For this valve, the normal position is position 1, which allows unrestricted fluid flow through the open ports. Therefore, this valve is a normally opened valve. Additionally, this valve is a spring return valve, meaning that after it is actuated, a spring returns the spool to the normal position. A spring symbol is placed next to the block representing the normal position. Actuators used to change valve positions can be mechanical, pneumatic pilot, or electric solenoid. To complete the diagram, the primary actuator symbol is placed on the other end of the graphic symbol. In this case, the actuator is a push button. Mechanical actuators change valve positions with springs, push buttons, plungers, levers, and cam rollers. Pneumatic pilots change valve position with a pressured air signal. Electric solenoids that change valve positions by directly moving the valve element are called direct solenoids. Electric solenoids that open small pilot valves and allow pressurized air to move the valve element are called solenoid-controlled pilot operators. Here is a similar valve to the one previously shown. It has two ports and two positions, so it is also a two-way, two-position valve. To illustrate the differences with this valve, let's build its graphic symbol. It is a two-position valve, so the graphic symbol will have two adjacent boxes. This valve also has two ports. However, in the normal non-actuated position, both ports are blocked. Therefore, it is a normally closed valve. When the valve is actuated, fluid is allowed to flow from the pressure port to port A. A spring returns the valve to its normally closed position, and a push button actuates it to the open position. Therefore, this valve is a two-way, two-position, normally closed, spring return push button operated valve. While it is similar to the previous example, the differences in the normal position make it a distinctly different valve. The most important applications in fluid power for three-way valves are for directional control. Here we have a typical three-way valve with two operating positions. This valve has an inlet port P, exhaust port E, and output port A. In its normal position, inlet port P is blocked and outlet port A is connected to exhaust port E. The second position allows fluid to flow from the pressure port P to outlet port A and blocks exhaust port E. The valve is also spring return and push button operated. Here is another three-way, two-position valve. This valve also has an inlet port P, exhaust port E, and output port A, but they are in a different configuration. In its normal position, exhaust port E is blocked and fluid flows from pressure port P to outlet port A. The second position, pressure port P, is blocked and allows fluid to flow from outlet port A to exhaust port E. The valve is also spring return and push button operated. Three-way directional control valves have many applications in fluid systems. One of the most common applications is for the control of single-acting cylinders. In this application, fluid is pumped from a tank to pressure port P. With the valve in the normal position, fluid is blocked. When the valve is actuated, fluid flows from pressure port P through outlet port A to the cylinder. The cylinder extends and remains extended until the valve changes positions. When the valve de-energizes, the spool returns to position 1, pressure port P is blocked, and exhaust port E is opened. The cylinder retracts and fluid flows from the cylinder through port A and out exhaust port E. From there, the fluid returns to the tank. Here's a graphical rendering of the same system using symbols as they would appear on a schematic diagram. Two- and three-way control valves are ideal for use as directional control valves to operate cylinders or hydraulic rams, filling and draining tanks, as mechanical brakes, and even in vacuum systems. Their versatility is vital to the successful operation of many different fluid systems.